Excellent. Well, welcome everybody. Welcome to our next Magnitude 10. This one's on RISA Floor, a new software we've been kicking around for, let's say 2 or 3 months, maybe a little bit longer. I think Tracy had the idea, or maybe Veronica did, to check this out for doing multifamily. I know there's probably Tracy and then Veronica shaking her head. But anyway, to do the more complex stuff, because it's relatively simple to model. It handles the repetitive stuff really well, and when things don't stack, it deals with that to the ground pretty well too. And our India team, led up by Kastur, has spent a lot of time investing in this and figuring out how to do it as well. So hopefully they're on, and it looks like a great production tool. So with that, I will introduce Harry and Amaya from our Reno. Actually, Harry's in Reno, but in the San Diego office, and Amaya is in Reno, in the Reno office. And let them have at it and show us what this is all about. Thanks, Harry and Amaya, for volunteering to do this.
Oh, thank you, Jeff, for the opportunity. So good afternoon, everybody. Like Jeff said, this is Harry Boughan, and I'm mostly doing the presentation part. And the entire presentation was put together by Amaya Davis in our Reno office. And in addition to that, I would like to also thank Veronica and Dan for all their input. When we were putting stuff together with presentation as well as the content. Now, real quick before we start, I'm just going to say, real quick, this is not a tutorial for how to use the program, and also this is not about any promotion to this. This is more about what we experience working with the program and how we think, talking about both the pros and cons of it and how we think we can go on from here, how we could use it to the best of it. So real quick, what we will be talking about in the program, throughout this presentation, we'll start with the market sector that's best suitable for, where we can use this program. And then we'll real quick talk about, what our old approach was to design and how the new programs can be of benefit. Now, this won't necessarily be limiting to RISA Floor. We'll also be talking about RISA 3D a little bit, because both these tools kind of go hand in hand for the overall design process. And then finally, we'll go talk about the benefits and drawbacks of the tools. And then it's not necessarily that this is about it. There could be more or less to that. This is just our experience with it. And quickly summarizing it, we'll go ahead and take some questions. So the best suitable type of projects for this tool is multi-story housing projects or hotel buildings, typical 4, 5, 6-story structures. Senior care living facilities, the type of structures where it's mainly wood components. It's repetitive stuff. We have stacked designs for the in our perfect world, we can dream of having stacked designs. So those kind of projects where we have multiple wood stories, they can copy paste it from one level to the other. Those are the best suitable projects for where this tool can actually be used to its maximum capacity. Now, why are we talking about this? Yes, all of us here, mostly are engineers, we have been calculating out stuff for a long time now. Why are we talking about this? Well, main thing is it's getting pretty competitive. We are not getting it for all the time that we actually put in. There's so much competition out there that we just don't have enough fees, and we have to find faster ways of doing things. Next thing would be with our traditional calculation approach. We have a lot of different components that are being put together from when the project starts to the end. Now, we start by developing loads. Eventually, that goes into applying those loads to the structure, and then from that point to each and every component. For a typical wood building, each joist is being checked. We have each post, developing loads for all those things. Now, even to use those tools, we do not have one program that does it all for you. It's more about, we start our design in a one spreadsheet. From there, we take the numbers, we go to the next, and those numbers are then taken into, a program which could be NetBuild, Calc, or something like that, where we are checking each joist. And then we have a program where we check the post, columns, all those things. And then eventually we do the same process for the lateral system, where we are checking diaphragm in our spreadsheets. I mean, now again, everybody has their own ways of doing it, but you could be checking diaphragms in a spreadsheet. And we have a separate spreadsheet where we're checking shear walls. Now, each and every shear wall is checked separately. So adding all that together, we have so much room where the error could be made. I mean, just taking numbers from one spreadsheet to the other, there's more chance. The more steps we take, more chances for error. Now, this is where, now these are some of the drawbacks, or we can say some of the things that can be bettered if we have tools where we can design all the components in one go, with a single run the program tool for the most part. Okay, so yes, we talked about why even though we do those calcs on a daily basis, but how can we better them? RISA Floor. RISA Floor, I mean, in a quick way to sum it up, I can say this is more or less like, how we use RAM steel for steel components. I mean, it used to be the same way, where each and every component would be designed by its own. We would design every single beam, and now we can model. And RISA Floor provides us the same capability for wood structures. We can model the whole thing, entire building, and once it's in there, from that point, we can go back and check all the components. Well, I shouldn't say all the components, but we can say good chunk of components in a single run. Now, just real quick talking about, the pros of it. I mean, not necessarily pros, but how is this more beneficial compared to our traditional design approach of, a bunch of different spreadsheets or different design programs. Now, the good thing about this is it's going to design good chunk of first wood elements, including our joist, post, columns. It could also do the lateral components or shear walls and all those things. It does do a pretty thorough design, and it's not only limited to the wood itself. I mean, we could have a longer span or something where we have a steel beam going on or some steel columns, those things can be integrated in the same model too. So it's going to check the wood as well as your steel for you. And then it's a much beneficial tool where you are doing everything in one program. It's not about, going into different steps, less chances of making any bookkeeping errors, like I said before. And then the really helpful aspect of this is it's so much more convenient to make the architectural updates. I mean, like I said before, one thing, our design fees are really shrinking. On top of that, I think it's rarely that we find where architect, even until the day before we submit, gives us his final model. It's never the case. I mean, it's always evolving. So, it's just one step easier. I mean, architect comes back with, okay, hey, I need to add a window here, or this wall can't be here. It's instead of going back and redoing our hand calcs or opening each spreadsheet again, we can just make a quick modification in the program itself, and we should be good. Okay. Nextly, now, real quick talking about the benefits. I just want to say again, this is not a tutorial of how we are going to use, even though I'll try to show some show the program here, just so that everybody who has not used the program before can see what it looks like and all. Now, from our experience using the tool on a couple projects now, what are the benefits? The biggest benefit that I think we as a company can utilize is we have help from our India offices, Nepal offices, where we can send it for modeling. Now, that could take away some time that our engineers here are spending, which could be utilized in other projects, and the model can be completely, put together by our overseas offices, which, in many, it could be cheaper for us. It could leave us with more time working on some projects here. And eventually it's just the analysis stuff that we can do here. I mean, again, it could be an office to office variant, but this is something where we have that option. I mean, once a schematic design set is put together, that set can be sent overseas with, our architectural information, with our Revit models, And all that information can be used to start putting together the RISA model for this. The next good positive of having a tool like this is it's very much more convenient to transfer between engineers. Now, I mean, even in the same office, you'll have multiple people using different tools for designing a shear wall. I mean, somebody could be doing completely in a spreadsheet. Now, once those tools are being sent to a different engineer, you know, there could be some time, okay, what's this sheet? Or even though it's the same calculation being done, but there's always about, you know, what's happening or how is this particular spreadsheet working? Well, the good thing about having a tool like this is it's a standardized process. Whatever's in the program, it is what it is, you know, so it's not that, okay, you know, if Mr. X did this and he's passing it on to somebody else and, well, they're having to spend time to understand the spreadsheet. No, I mean, it's about same tool that everybody else is using. We can easily transfer this from one person to the other to, you know, run different aspects if we want. If somebody else is working on lateral design or gravity design, or even the overall, I mean, if we have an engineer who's switching to a different project, it's so much more convenient. Nextly, it's anything that's faster, it's cheaper, and it's more profitable. And now adding this to our shrinking design fees or not having enough design fees for projects that we would like to in the perfect world, it's more beneficial. I mean, if we can, once the model is all set, from that point, it's just about the analysis. And lastly, the biggest benefit of this is, you know, it's a much more fine-tuned analysis that we are doing. Now, you know, typically all of us, you know, it's during checking different joists or whatever, I mean, there's always some safety factors or there's some level of conservatism, you know, okay, the trib is this, you know, let's just say it's rounded off to 24 inches or stuff like that. You know, those things are then being modeled in a program like this, it's going to be modeled exactly what it is compared to adding those extra, you know, factors here and there. So all those things, you know, when put together, I mean, we do have a pretty competitive tool that can help us with different aspects of the project. Any questions with anybody has at this point before we start talking more about the drawbacks and you know, how the tool works and stuff? Okay, I guess no. We'll move on to any drawbacks that we see in the program. Yes, we definitely do. Well, again, it's not a perfect thing. You know, it's a relatively newer tool that people have started using lately, and the biggest drawback, well, it's not necessarily a drawback, but for us as a company, what can be there's a learning curve, right? Again, it's an initial thing, but once more or less everybody is trained with that, we have more, you know, once our staff in India or overseas staff is more trained to model to put the model together, it's going to take less time for them to do that. And then once our engineers here are more trained to understand the program better, you know, they can run the program better, we understand how it exactly works, you know, we're going to take away a lot of analysis and calculation time, you know, from doing the hand calculation traditional approach to this. But the initial set of learning the program itself, yes, it's going to be some time, but once we have overtaken that, we should be in pretty safe spot. And from our experience, this might not be exactly true, but from our experience, if we have a stacked design, the program works very clean. There's more or less, you know, the least amount of issues. Now, not saying that the program would not work for if we have unstacked designs in those situations, but it just performs a lot better for stacking designs. And then RISA has some limitations which they're constantly working on. And again, it's one of those things, you know, more heads start working on this, more people start thinking about this, you know, it leaves the developer with more opportunities to fix those issues because more questions they start getting, more chances of them being improved. And so it's just more or less an evolving process. And now talking specifically about one of the things that we think in a situation where we have a post in middle of a shear wall, which is like all the time kind of a scenario, you know, it would not design that as one single shear wall. It would break the shear wall into two components if we have a gravity force coming down. Now, all these things, I mean, there's definitely ways around these. You know, we can work around that. We can still get the results. It's not about that, you know, this is where the program failed. It does do the analysis. It's just that it takes a slightly different approach. And these are things that can be overcome in the future with, you know, with improvements being made to the program, or even it's possible that, you know, it's something that we didn't know, or, you know, there's way around that we can make it work. And lastly, a couple of things. I mean, just like any other tool, these programs, I mean, they're decent sized programs. They can crash. You know, you're running the program, it takes time. It's not something that's quick. You know, it takes time to run the analysis to get the final results. You need to save. That's the biggest thing. Okay, I did all the work and I forgot to save. You know, I mean, those kind of things that typically come with any design software. We could have the same things with this program too. But I mean, we have been using softwares for a long time now. It's just that we have never had something like this for wood structures where, you know, we can just we can design a good chunk of components in a single run. I'm going to summarize real quick. So talking about, you know, what we had, I mean, this is more or less like having a design tool where we can design the entire structure, basically, entire wood component structure with some lateral steel elements and all that. We can definitely analyze that in a single go. I will actually share the screen where we have the model that was one of the podium models that we did. We'll take a look at that. Now, compared to our traditional design approach, we do have a lot of pros, you know, of having a single component, less chances of errors, you know, when we're doing it all together, and overall just less collateral brain damage. I mean, now this is all once we have a staff that's good, that's trained, or once people have started using the program for a long time, and more or less like any other design tool, any software is only as good as the information that's being fed to it. I mean, if it's garbage in, it's going to be garbage out. You got to know what we are modeling. You got to understand the wood design correctly. And once we have that knowledge, you know, from that point, you got to go and enter the components correctly. If all that stuff is done correct, we can expect a pretty good design. Before we actually start questions, I'm going to share the screen. So this is this is the actual model this is the picture that we had on the first slide. This is the actual RISA floor model. My computer might be a little bit slow here, but if you can see, each one of those joists is modeled in, all the walls and everything. Basically, this is like having a like a steel ram model or like a full-on Revit model. Now, RISA does have RISA and Revit links. Now, I have specifically not tested those for a tool like this, but once we have a completed model from Architect, we can explore into, you know, if somehow we can use that Revit 3D model to come up with this. I mean, it's not tested thing by me, but, you know, we have those tools available. So this is just a full model. And the positive of this is, like I said, now, specifically for stacked designs, once you have modeled the first floor, it's just a copy and paste thing that goes up to top floors. I mean, little tiny modifications for each level, yes, they can always be done, but more or less for the overall project, you know, the layout is usually similar for projects like for hotel buildings or, you know, multi-story residential stuff. More or less the project layout is the same. So we can just copy paste. So it's easier and more convenient to just copy it and come up with the overall model. Now, RISA floor is good for the gravity components of it. However, we do define all the lateral components in the program tool also. And once the gravity aspects are designed in RISA floor, we can take this model, transfer it into RISA 3D, and that's where all the all the lateral components can be designed. So it's not just that you're putting in all the modeling work and you just get the joist design. Now, you get all the forces and everything applied in RISA floor. And this component, now what you have to do is, I mean, which is pretty typical for all the design tools, you know, where we have different program tools, and we would just assign the members, okay, if this is a gravity only member or this is a lateral member. And then depending upon how those members are assigned, we can take this model and it can be transferred into RISA 3D, where you can run the lateral aspects of it. I'm going to try real quick to transfer this into RISA 3D just so that we can see what it looks like. So, and it's the transfer process is actually pretty easy too. Once the model is run in RISA Floor, anybody who's familiar, we have the director tab up here. From that point, it's just about selecting RISA 3D. It might take a minute or so. Ignore that. Now, this is where you can actually, before you transfer, you can enter all the seismic information in here. What codes we are following, we can calculate the seismic loads. You know, so any dead load, I mean, any structural, the seismic loads from the structure itself, they can be applied, but we're not going to get into all that. Just see if it would just transfer the model into that and see if we can have 3D layout for RISA 3D. It's going to take a minute. Any questions in the meantime, or anybody wants to chime in with any?
Hey, Harry, I wanted to throw one thing in. One of the biggest challenges with the residential pieces of projects like this is they want to have almost all glass on the outside, right? We don't get any shear wall on the exteriors, which is where we want to have it. So the nice thing about this program is it has that ability to take the diaphragm and work, you know, with 3 wall lines that are not the exterior wall to get, you know, that torsional part figured out, and we get that load into the shear walls we do have. That's cumbersome by hand, and so this is really helpful in this program. That's one of the big benefits too of trying to get the model to do that work for you.
Yes, definitely. Now, I mean, it's easy to get the torsion done and just transferring loads into the, you know, the 3 walls, but getting the deflection aspect of it, you know, the program does it pretty good for you. I mean, it's pretty well modeled. You can assign the diaphragms. I mean, if it's a flexible diaphragm, you know, or semi-rigid, rigid, once all that stuff is assigned, the program tool works pretty good. Okay, so the transfer process seems to be pretty much complete.
Harry, sorry for interruption. While we're waiting for that one, may I ask you a quick question? This may
sure.
be a little silly question. So on the model, like, looks like we added every single joist, right, on the model.
Yes.
And you copied up the floors above. Like, do we really need to add all those joists? Looks like
no. So I mean, you don't go back and draw each one of those joists in. You can basically select the area, select the joist, and those joists are put in depending upon the parameters that you put. You know, you have what joist and what spacing. It gets assigned to that area.
I see.
So it's not like doing a, you know, a regular 3D RISA model where you're drawing each one of those joists.
Right. Yeah. That was my question.
Yeah. I mean, again, for the looks of it, once you're looking at the 3D aspect of it, you can get the feel of it. You know, many times when we're putting a schematic design set together or something like that, you know, there could be a location where we're missing post, or, you know, I mean, there's only so much we can do with looking at the plans. But once we're looking at the 3D aspect of it, you know, it makes it more convenient to catch errors like that. Okay, so there you go. We have. Now, again, it's going to bring in all the lateral components into the 3D aspect of it. So I'm going to do is so right here. So if we can see now every single wall, basically this is a shear wall thing overall. So all those walls have been brought in into the 3D RISA 3D module. With the openings, if we have any wall openings that have been brought in, I'm just going to real quick show one of the wall openings. Now, this is where you can define, you know, if it's a shear wall, what type of a shear wall it is. You know, if we have any openings in there, take into account all those aspects of it. Other than that, I mean, yeah, this is, again, I'm not going to run any of these tools because it takes time. You know, these programs can take some time to spit out the results, but But just wanted to give everybody a feel for anybody who has not used the tool itself, to see where we can start with the program and where we can end. Now, real quick, since we showed this transition process from RISA Floor to RISA 3D, a couple of things that I do want to say is, because this RISA 3D version that we have here has been brought in from the RISA Floor model, so we can't make any changes in here. So any changes that we do, they have to originate in the RISA Floor version of this. And then once we have done it, they made the changes there, then we can, retransfer the model into RISA 3D and do the lateral analysis. Now, this not only brings in the shear walls. I mean, if you have any other components that are assigned to the lateral aspects of it, all those components will be brought in. So this is about it. I mean, it's real quick. Yeah. Also, it's not only it's gonna trace all the loads all the way down to the foundation level. We do have those loads. Other complicated thing that at least I have experienced, which I believe everybody has pretty much. It's not a complicated thing. It's just it's so much more time consuming. Is tracking all the loads from the top floor down to the bottom. Now, it's easy stuff, but it takes so much more time. And if you have everything modeled in correctly, it's just about running the program. I mean, it's not as simple as just running the program. I mean, we can't just completely trust the computer tool. It's again about what you're putting in. You have to have the understanding of how the wood stuff works. You have to have the understanding of how the program works. But once you have those, I mean, you are still the design engineer. It's not that we can just take whatever the tool's saying. And then at that point we just run, or we just see how the program tool's working, and it's about it. Going back to our presentation, I think this is it. So any questions that we have?
Hey, Harry, I'll throw one other thing out there. We tried in theory on that project you had up. LA did the podium. Thank God they did the podium. There was a hope that we could bring the reactions in off RISA 3D and drop them into our program for the podium, which I believe they're using ADAPT, or I'm not sure. You'd have to ask James what he was up to. That did not prove successful in this project. There were some hurdles, but that doesn't mean we're not going to get there. And that's just really important. I mean, how much time saving can we have there? That would just be tremendous. So yeah, we're working with RISA. We're reporting back to RISA, I think, and they're trying. So it'll catch up eventually. So if someone finds this not beneficial now, 6 months later, the world could be a whole different thing with this program. So just some food for thought on that.
Yes. Yeah. Like I mentioned, the RISA Revit link, RISA does have a lot of other links, which go with ADAPT and different tools. I mean, just talking about the RISA Revit link, it's a lot better now from what it used to be from when last year run. So again, you can, like Veronica mentioned, we can take this model once everything's run in RISA 3D. We have all those foundation reactions, including hold downs and everything down at the base level. You can transfer that into an ADAPT model if that's being designed for slab. Or whatever tool we're using, and if we do have a link, and then we can just run that tool. So basically, all those things tied together, and instead of manually taking forces from one point to the other and applying them in different programs, it's more about just transferring them from one aspect to the other. And yes, those transfer tools, the links might not be perfect at this point, but if we have more people starting using it, more information being reported to the software developers, there's always chances for improvement, and we could have a much better functional tools down the line.
I got a question. And maybe I missed this up front, Harry, when you were introducing this model, but were you able to pull in any data from a Revit model, or the architect or anything like that? Did you draw the grids from scratch, or did you export those in from a Revit model to get those dimensions correct?
Yes, so I think for this particular project, it was all done from scratch. Amaya was the one who did this model, so Amaya, correct me if I'm wrong here, but I believe it was all done from scratch. However, the program does have the capability where you can bring in the grids from, if you have a grid system somewhere, now you can bring in the grids from CAD. So there's a DXF format, I believe it is. If you have the grid lines saved as that, you can import those grid lines in, and once you have those, you can start drawing in from that, from those grid lines. And in terms of bringing in the information from Revit to RISA, not for this particular project. I have tried it just for fun in the past. It does bring in the information, but the issues lie where, how architect is modeling it. Now you have to, again, it's one of those things, when you take the program from RISA Floor to RISA 3D, how we say things have to be modeled correctly in RISA Floor for us to transfer them into RISA 3D. It's the same thing. The things have to be modeled correctly in Revit, and that from that point, if all that stuff is, if all the components are defined, okay, this is a steel component, and those shapes are defined correctly, and the wood component shapes are defined correctly, from that point, we can take the model and transfer that, yes. But I mean, it's not often that we would find, things perfectly modeled by architects. I mean, it's more or less about the level of detail that we go to in the Revit models.
Hi, Harry.
Yeah.
I have another question. So the model that you're sharing with us, how long would it take to create the model and verify input and output?
That is a very good question. Amaya, do you want to chime in to, to see how long it took you to model this? Now, again, but before Amaya does that, I just want to say real quick, it's about, if you're a beginner, it was definitely going to take you a lot more time. But I mean, once you reach the level where, you know the tool pretty well, it could be a lot faster than what it would take you to begin with.
Yeah, so I was working on this for at least a couple weeks. Not the full week, but over a couple of weeks. But as Harry said, I was a beginner, and also there were architectural changes, of course, going on. And then that's also with Dan checking as well. And I think Harry mentioned this, but just to really hit it home, it is important to have some wood knowledge when you go into this, or have someone looking at it who has wood knowledge. So as like an entry staff engineer, it was really important that Dan be looking at it as well, because he knows how wood works better than I would understand. But I would imagine as you get more experience, and especially with repetitive designs, that you could go through it pretty quickly if you were able to copy the floors up and just make slight changes.
Yeah.
So Maya, I have a follow-up question. Since you have done this one, so let's say if you have to create the same model once again from the scratch, how long would it take for you?
Probably, I mean, less time, of course, but again, I would think it would be important for someone to be looking at it who has more understanding, to ensure that it's being modeled right, so that when it goes into the 3D model, everything is transferring correctly.
From my knowledge with working with the tool, from all the RISA 3D that I have worked with, I would say, once you have a better understanding of the project, you can do it in about less than a week. Now, again, the benefit of that is this, I mean, traditionally when we are hand checking it, every single one of the shear walls has to be calculated. I mean, the way I have done that is we have spreadsheets. Now, when you take force to each spreadsheet, you go back and run each one of the shear walls at all the levels. I mean, depending on, what the circumstances of what the project is. So it's what we do is basically, we are taking away from the analysis time, and we are putting some time in upfront in terms of modeling. And once that time is put in, we have less time doing the analysis. I mean, yes, once the model is completed, you'll have to go around, you'll have to look around, understand, if everything is modeled correctly. And then once you get to that point where it is, from that point, it's just about, running the model, and the only time consuming aspect that one I would say is, just running the model itself, because it can take some time doing it. Now, I think for this particular project, just to give everybody an idea, it was about an hour to hour and a half-ish from what I've heard from Dan and Amaya, to completely run the model and get the results.
Hey, Harry, I have a question.
Yeah.
What is the analysis like fundamental of the RISA on the wood? Is it finite element analysis, or it's just a distributed force and panel panel check?
Hey, can you say it again? The last you were cutting out a little bit.
Can you hear me well now?
Yes, yes.
I'm asking what is the fundamental of the analysis? What kind of analysis they do, if you know? I mean, is it finite element analysis or just based on the force distribution and the panel check?
Now, I could be wrong, but once you get into RISA 3D, it does do finite element stuff, the way it's applicable. And for RISA Floor, it's mainly about the force distribution stuff.
Got it. So for this wood things that you showed in the RISA Floor, I think it's a force distribution.
Yes.
Got it. One more question. I don't know if you or Veronica mentioned, but is it possible to model the wood building over the concrete podium? I mean, both material on one model.
No. So again, I can't say if it's yes or not. If it's, I mean, I don't know. We haven't tried doing the podium at the same time in this model. However, this particular model that I was sharing, it was a podium structure where, you know, this entire wood structure was on top of a concrete slab, a raised concrete platform. So the approach taken here is, you know, we did this design for wood separate and the design for concrete stuff separate. But we have not tested doing it all together in one program.
Okay, so you did two-stage analysis.
Yes, yes.
Got it. Great. Thank you so much, Harry.
Yeah, no problem. And this is where, you know, you can take the results from the RISA 3D model. Now, again, you know, we have not tested with, I mean, no, Ron did say that the I think LA office did try doing that with ADAPT, but, you know, I can't speak for how effective it is and if it's actually worth it, you know, just taking the forces from the 3D model and transferring them into a different concrete software.
Got it. That makes sense. And I have one following. Do you guys know any other software that we can model the like a wood building there?
Something like this, I would say, me personally, no. I mean, I would say that for me, again, you know, this is just speaking from my knowledge perspective. I think this is the most complete wood software that I have seen so far, where we can put all those different components together. Now, I'm not saying there is not other softwares out there, definitely could be, but this is the one that we have kind of worked with and have some slight bit of experience now.
Great, thank you so much.
No problem.
I have a question, Henry.
Sure.
So we can import the model into Revit. How come when it comes to like generating the drawings, do we still have to mark up each shear wall, the joist, and put all that annotation, or the program pretty much when you import, it generates these annotations and you have more or less complete markups on the drawings already?
Yes, so if I understood the question correctly, I think it was about taking this model and taking it to Revit. Now, I have not done the backward process, and I do not know if we can take a 3D model and put that into Revit. But just on the side, I have done some transferring the Revit model to RISA. I've tried that, but not tried doing the RISA models into, you know, if you develop a RISA model from scratch. I have not. I'm not sure if that's possible to take that into Revit.
Actually, the question is, when you import your model into Revit, do you get the information on the plans, or do you still have to go and mark up by hand every single information, like this type of shear wall we need here, this type of joist we need here, this type of beam, or does it automatically import all that information so we can just print the plans and the information there?
Yeah, no, okay, so I just want to, we cannot develop drawings from this, no. We cannot take this 3D stuff here or RISA floor model here, and we cannot transfer it to develop drawings. No, we cannot do that. All that stuff still has to be done, you know, by hand with our typical design process. I mean, typical process where we put together the drawings and we have to basically call out different components in the drawings separately. This would not, at least from my knowledge, this tool cannot be used to develop the drawing sets for the project, no.
Okay, thank you. Also, there is another program that that's very similar, and I think they've been working on it earlier than RISA started doing this. It's called Robot Structural, I believe, is the Autodesk program. and it's very similar what you just explained. I never used it myself, but you can use wood, concrete, you can do wood over podium, all that, just for answering the question prior to this.
Sure, yeah, no, that's good to know. I mean, like I said, there's tools, we have been doing this for steel for some time now, where we have been using the design softwares that are available. But for wood, I had not seen these being used a lot. And now that we have options, I think this might be the time to start chiming in and, seeing how we can use them to our benefit.
Yeah, thank you.
Hey, Harry,
Yeah.
I have a couple more questions.
Sure.
So once you get the outputs, how do you verify whether those outputs are correct or not?
It's a good question. And yes, I mean, now, I think you could, it's a factor of, if you have some analysis done on site, hand analysis done, if you want to compare it to that, there's definitely spot checks that I would say should be done. I have personally not run the full 3D model to, get the results and do the analysis. So I cannot speak for that. Dan in our office was the one who was mainly doing the 3D aspects of it and doing the lateral designs for that. So he can say better with how those spot checks were done. But for gravity spot checks, that's easy. If we just pick and choose a few joists that we have, we can basically just run a few individual joists just for comparison purposes to see what we're getting from the program.
Right. I believe Veronica mentioned that it checks, building torsion, all that kind of stuff. So I was wondering how you would be able to spot check building torsion, reactions from building torsion.
Yeah,
Yes.
Suman, to clarify, what I meant is if you have a given unit and it has 3 good shear walls and you're missing that 4th to get the box, that's where you're doing that that flexible diaphragm and taking almost a little bit semi-rigid and distributing in torsion to those walls. Because we're just not getting the shear wall and the exteriors like we normally do, or we'd like. So that's a huge benefit, is picking that up, is doing those. It's going to do it on the global scale, but I'm specifically taking advantage of that macro or micro scale of the individual units. And regarding the understanding if you're getting reasonable results, that's why we keep stressing, if you don't do wood, this is not the program for you, because you won't understand how to model it to create those links that need to be done in RISA Floor to bring it into RISA 3D. And Dan's probably leaning pretty heavily into his experience with wood to know if a 6-inch nailed shear wall is reasonable at the bottom floor. Probably not.
So Harry,
There's a question I think it's from Carl on the chat room. Does this integrate with their foundation design?
Now you can take RISA 3D stuff and you can transfer that into RISA's foundation platforms. You can do that, but yes, you can. Now I do not have any experience, and I don't think on these projects we did that. But how we were able to actually take the RISA Floor model and bring it to RISA 3D. Same way, once you have the 3D model, you have run the analysis, you have the forces, you can transfer that into RISA foundation. But I cannot speak for how effective it is, and if it works pretty smoothly or not.
It's good to know. And the other question was, does it do vertical shrinkage for the wood due to gravity loads?
I cannot say for that. That would be other thing that I would say Dan can probably. We can get back to you with the response to that.
Okay.
Jeff, Jonathan Buckley had a great question about, does the program calculate force transfer around openings analysis per code requirements and perforated opening analysis per code requirements? And Dan chimed back to me, yes, it does do that.
Yep.
You can define all the shear wall types. If it's a segmented wall or whatever wall type it is perforated, once it's correctly defined in RISA 3D, again, for this program, if you're just doing a shear wall in RISA 3D, yes, that's a different aspect, but for how we are talking about it, when we transfer the model from floor to that, as long as everything is correctly defined and you're picking up the wall segment as, whatever properties you assign to that, it does do the analysis from that point, yes.
Well, that seems pretty efficient.
Yeah. Another
Yes.
question that JB had, he was asking, what is LA and SAC office using? Just FYI, we are the office out of the northern team, so we consider ourselves part of SAC. As far as I know, I think Letitia mentioned something, but I think we've taken it, dove into the pool the deepest so far on that. LA is having communications with Dan because they have some very large projects coming up where if this works, they're going to leverage their ability with India to really deliver the projects more economically. So as far as I know, this is the program still being used in the offices working with wood.
And to say it again, I mean, the programs are only as good as the information that you as a user put in. I mean, if you have a good understanding of what you're doing, you need to know the materials that you're working with. You need to know what the program, what kind of analysis it's doing, and how does it take different components into account. If all that information is understood from that point, it's pretty convenient.
Yeah, I would think if you can't answer those questions truthfully to yourself, you probably shouldn't be using the software.
Yes.
Unless you're fooling around and trying to figure it out. But honestly, you need to have some understanding of the basic, engineering tools that we're doing.
Yeah. And then other thing, I think I said that, but just to say it again, I mean, once you're putting the RISA floor model together, you assign different components. If this is a gravity only component, or this component takes the lateral aspects too. And then once those aspects are modeled in, based upon that, it's going to know what elements to transfer to this 3D model. Any other questions?
Michael has one in the chat room. Can you see it, Harry? It says, any issues with accurately capturing deflections from shear wall nail slip as well as from traditional hold down straps versus continuous rod HD systems?
Okay, I can see that now. Again, that's I cannot perfectly answer that question right now because I said, Dan was the one who was kind of running the 3D lateral analysis of it. So we can definitely get back to you with this question. I don't want to just say yes or no to that until I've confirmed with him that what was his findings.
Okay. Then another one from Carl. Does it do dynamic analysis?
RISA 3D by itself has the capability, but once you're making the tool work with RISA Floor as a combination, I cannot say. I mean, we haven't done that to see if it does it or not. But in RISA 3D by itself, yes, it can do that. So, I mean, I can go by the assumption that if the program has the capability, it can. But again, it's not something I have done and tested with that to see how exactly it does it and how does it work.
I have one last question, if I may. It's about practicality. So when we design wood, we usually do a lot of simplifications. So we keep all the walls on the same line, having the same sheeting, and we specify only so many different sizes of the joist and beams. So when you do this program, is there a way to control that, or is it going to just generate like 200 different types of shear walls and then 20 different sizes of joist? Is there a way to control that so it's practical? Because we are not going to put that on drawing. We're going to simplify eventually.
Yes, you can assign it. I mean, if you can assign it different properties. If you assign, okay, these are the 4 wall types that I want to have on the project overall, then it's going to run everything between those 4 types and give you results based on that. It's not just going to randomly give. I mean, if you don't have specific things assigned, then it's going to give you any random results. But you can always pick and choose. Okay, my joist depth is limited by 16 inches. Anything between 16 and 18 inches, or whatever you have. As long as those different aspects are originally assigned, and then the program just going to run the software within those limits.
Okay, thank you.
Yeah, I mean, typically for these projects, you would want the same floor joist throughout the floor, and the plate heights all want to be the same. So you want a lot of repetitiveness in it.
Yes, And that's where you can assign the depth. I mean, you say, 60-inch deep joist, then it's gonna work within the limits of that.
Excellent. Is there any more? We've got 4 minutes left. 30 minutes of presentation and 25 of Q&A and discussion. So I think that's a good topic then. A lot of interest. So thanks, Harry and Amaya, for putting it together. I appreciate the time spent, and thanks everybody for joining. We'll give you back looks like 4 minutes now, maybe 3 minutes of your day. So we'll see you next time. Look for the next look for the next invite soon. Thanks, everybody.
Thank you.
Thanks, everybody.
Thank you, everybody.